Okay, good evening. Good evening, you guys. Can you hear me? Can you hear me? If you can hear me, let me know. Okay, that's very good. Okay, so I'm going to. Okay, by the way, who was the first person? Okay, it looks like that was Rubik's. Okay. Okay. So, can you guys see my screen? Can you see my screen? Okay. Oh, Darasimi came before Rubik's. No, really? Even though that was the first message I saw. So what's the proof? Even though the first chart I saw was Rubik's chart. Oh, that's nice. Okay, Mackenzie, send me the screenshots. Let me see. Okay, please give me a second. Give me a second. Okay, by the way, can you see my screen? Okay, okay, okay. Just send me your proof and then I will decide, okay? So I'm sure that we can all remember where we started the last time. We were looking at measuring tools. So in our last class last week, we stopped at vernier caliper. Okay, we stopped at vernier caliper. And so today we are going to look at micrometer screw gauge. Very important. And I like the fact that some persons sent me their work. Some of you don't send me your work. I don't know why, but you know, some of you sent your work actually, and it was quite impressive. So today we are going to look at vernier caliper. And already, if you can see from my screen, that is what a vernier caliper, that is what a micrometer screw gauge looks like. You can see the name there, micrometer screw gauge. Okay, so I'm about to share my note screen. Okay, can you see my new screen? Can you see the new stuff I posted? So now you can see that the micrometer screw gauge is used for measuring very small dimensions accurately. Very, very small. Now what the micrometer screw gauge can measure is quite smaller than what the what is it called now? Is smaller than what the vernier caliper can measure, right? That is one thing I want you to note and remember. Then the next thing I like you to note is that look at some of the things you can use it to measure. You can use it to measure diameter of a wire. You can use it to measure thickness of a paper, something thinner. You can use it to measure diameter of small rods. And you can use it to measure the thickness of metal sheets. So you can imagine something that can measure the thickness of paper. That's it means that it has a very high resolution, right? Has a high resolution. So that's by the way. Now it takes us to the main part. Now the main part of a micrometer screw gauge, we have the frame, we have the anvil, we have spindle, we have sleeve scale, we have thimble scale, and we have ratchet. Okay, and we have ratchet. That's very important. Now and I already showed you a picture here. So this is the anvil, this is the spindle. It is what does the measurement. This is where you place the stuff, the micrometer screw gauge. Then this is the sleeve, and this is the thimble. Now actually the sleeve and the thimble is what gives us the actual reading. Of course, this class I'm going to be showing you how to read using a micrometer screw gauge. Then this is the ratchet, that's the ratchet, and this is the frame. Even though nobody is going to be asking you all of these details, usually in exams they only concerned with reading, how you use it to read, okay, to take reading, and that's all you should concern yourself with. But for the sake of, we are just doing this just for knowing sake. So you have the anvil, you have the spindle, you have the sleeve, you have the thimble, you have the ratchet, you have the frame. But this is where the reading is taking place here. This part here is like the main scale, just like you have in vernier caliper. If you remember what we did in the vernier caliper, we had the main scale reading and we have the vernier scale reading. That's the same thing here. This is the main scale and this is the other scale, which if we like we can call it the vernier scale. I hope that makes sense. Okay. So so far, have you guys followed me? Are you following what I'm saying? Okay. Okay, very good. Very good. Okay, so then let me go down to the resolution. Now you can see that the resolution of a vernier caliper is very small, 0.01 millimeters, which is 0.001 centimeters. Let us compare it with vernier scale. If you remember, vernier scale, the resolution of a vernier scale is either 0.1 millimeters or 0.01 centimeters. That's the resolution for a vernier scale. Either 0.01 centimeters or 0. But for micrometer screw gauge, it is smaller. So micrometer screw gauge can do a measurement that is much smaller than what a vernier caliper can do. Right? If you are following, just tell me yes, I am following. If you are following, just tell me yes. Okay, very good. So now let's see how the reading goes. Look at the reading. So in this case here, you take the sleeve scale, you read the sleeve scale. This is the process. Then you read the thimble scale. Let me show you the diagram again. This is the sleeve scale and this is the thimble scale. So you take this reading, you take this reading. When we were doing vernier caliper, we called it main scale and the vernier scale. But this time around, we are calling it the sleeve scale and the thimble scale. Okay, so then the next is we multiply the thimble scale reading by the least count, which is another word for the least count is the resolution. That's another word for the least count. It's called resolution. Then you add both readings. So the final answer will be the sleeve scale plus the thimble scale. Okay. Okay, good. Now, but before I continue, I like to know who can tell me what resolution means? Can somebody tell me what resolution means? Based on what we did the last time. What is resolution? Yes, I'm waiting. What is resolution? Okay, Gina, that's beautiful. That is the smallest unit. The smallest unit that an instrument can measure. Right? The smallest unit that an instrument can measure is what we call resolution. That's beautiful. The smallest measurement 18 can measure. Stop calling it 18. It's not 18. Okay? So the smallest unit that an instrument can measure. Remember the word instrument. It is instrument you use in measurement. So the smallest it can measure is what we call resolution. And I'm glad you remember this. Many students will not know this. The smallest unit that can be measured by an instrument. The smallest unit that can be measured by an instrument. Okay, Marian, good, nice job. Brian, nice job. Mackenzie, nice job. Gina, nice job. Okay, so let's go back to our notes. So now look at this example here. You have the sleeve reading to be 5.5. You have the thimble reading to be 28. And the resolution is 0.01 millimeters. Remember, this is in millimeters. Okay, so your answer will now be 5.5 plus 28 times 0.01. So the sleeve reading plus the thimble reading times 0.01. So it's going to be 5.5 plus this times this now will give us 0.28. And by the time you add it, this is going to give us 5.78 millimeters. Now, I want you to remember something. When we were doing vernier scale, the measurement was in centimeters. But vernier caliper. But for micrometer screw gauge that can measure much smaller, the measurement is in millimeters. So you can see millimeters. Okay. Now, before I continue, I want to be sure you understand it, even though it doesn't look different from what we've been doing. So, do you understand? If you understand, kindly note that yes, I understand. Okay, very good. Of course, it's not very different from what we did the last time. Okay, so I have plenty of examples here. I'm going to do one. You can see I'm ready for you guys today. And I'm sure you like that. So look at this now. I want to take this reading. Please watch. Now, first of all, from here to here, you'll notice that it is 1 count. Obviously, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Before the thimble is 11.5. Before the thimble is 11.5. Can you see that? Before the thimble is 11.5. So it's just like saying 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, and so on. So if this is 10 and this is 11, it means that here will be 11.5 just before this. So it means that the spindle reading is 11.5. Then this one, look at this. Look for where it merges, it touches. Here. From here to here, this is supposed to be 15, 16, 17, 18, 19, 20. But where it touches exactly is at 16, 17, 18. Is at 18. So that means I'm going to have 18 times 0.01. So the answer is going to be 11 plus 0.5 plus 18 times 0.01 will give us 0.18. So the answer to this will be 11.68. That is how you do it. That is how you do it. Does it make sense? Does it make sense? Okay, I'm glad you guys do. Okay, so I want to, let's try the next one. Go ahead and try the next one, B. Somebody give me an answer to this one. Darasimi and Tony, the both of you came late, but I will explain again. So just let the others respond first. I will explain again. So for the rest of you, can you do B? Okay, while the rest of you are solving, let me explain this to Darasimi and Co. Now, Gina, that your answer is very scary. So you start from here. This is called the spindle. I hope I'm correct. Then this is called the thimble. So you do the spindle reading, then you do the thimble reading. Let me be sure. Yeah, spindle. Okay, it's sleeve. Sorry, sleeve reading and thimble reading. So let me erase this. So this reading here is called the sleeve. So you start with the sleeve reading. It is from here 0. Since here is 0 to 5, it means that here will be 1, 2, 3, 4, 5. So you continue 6, 7, 8, 9, 10. Then you continue 11. Before the thimble, you have 11.5 because 11, 11.5. These ones down here are 0.5. Like you say 0, 0.5, 1, 1.5, 2, 2.5, like that. So this is 10, this is 11. But before the thimble, you have 11.5. That's why I have here 11.5. That's exactly what we have here. Okay. Then exactly, then you now check for the thimble reading. In the thimble reading, the line that matches this line, this sleeve reading, you can see where it is. This is where it is. So you are going to count from here 15. You are going to count 16, 17, 18, 19, 20. That means 15, 16, 17, 18. It is 18. That's how we have 18. So when you multiply 18 by the resolution of a micrometer screw gauge is 0.01. So you must multiply by 0.01 and that will give you 0.18. So 0.18 plus 11.5 will give you 11.68 millimeters. So this is the answer to the question. I hope that is clear though. So who has answered the other one? Which one are you guys answering that is 9.09? I'm talking of this, so this is the one I need you to answer. This one. B. Okay, somebody said 9.015, okay. Any other person? Any other person? Okay, Folake, your answer looks so powerful. Yeah. Darasimi and Folake got the answer correctly. You guys should look at what they've done. Darasimi and Folake got the answer correctly. Yeah, Marian, good. Mackenzie, you skipped one. Okay, so let me show this to you guys. Okay, Stanley, 9.50. Okay, let's do it together. All of you tried. So remember, you get the sleeve reading and you get the thimble reading. So the sleeve reading is, this is 5, 6, 7, 8, 9. You have 9 before the thimble reading. So it is 9, if you like, you say 9.00 if you want. Then this is 45. That means you count 46, 47, 48, 49. This is 49 exactly. So you can just say 0.49. Or if you like, you say 49 times 0.01, which is going to give you 0.49. So by the time you add these two, you are going to get 9.49. So for those of you that got 9.49, you got it correctly. You got it correctly. Yeah, so if you got it correctly, I want to see you celebrate. How did I get 9.00? I think that was clear now. After 5 is 6. After 6, 7. After 7, 8. After 8, 9. So it's 9. 9 is the same, whether I write it as 9 or 9.0 or 9.00 or 9.000 is still the same thing. Okay? Still the same thing. So Rubik's, I hope you understand that now. Okay, Tony George, I can see joy. Okay, so now let me move on. So can you try C? So somebody try C quickly. Let's try C. C sharp sharp. Oh. C sharp sharp. Dara, see me. That was too fast. Stanley 11.48. Okay. The 0 above the 49. Was there a 0 above 49? It doesn't matter. When I say 9.00, it's still correct. 2 decimal place. So for you to write a whole number in 2 decimal place, you say 00. Oh, okay, Stanley. Okay, so let's do it together. This is 10. This is 11. There's 11.5 before this. So you have 11.5. You can write it as 11.50. It's still the same thing. Whether I say 11.5 or 11.50. But the reason why I'm writing it in 2 decimal places because the reading are always in 2 decimal places. So it's fine. So I don't have to say 11.5. Then look at here. This is 45. So I can say 45, 46, 47, 48. So that means this is going to be 0.48. Taran! 0.98 is the answer. Millimeters. So if you got 0.98, you got it correctly. 11.98. You got it correctly, right? Yeah. Yes, Rubik's, you forgot the 5. But I think you got it later. So, Ami, I hope you can see your mistake. Folake, that was a good one. Enyoma, that was a good one. Mackenzie, that was a good one. Marianne, that was a good one. Okay, good. So, let's do the next one. D. So let's go ahead and do D. The Timbo, this is 45, 46, 47, 48. This is 45 already. 46, 47, 48. And your mind looks like you're on fire. I can see joy in Tony George's heart. Wow, these guys are on fire. You guys are on fire. I love what I'm saying. I love what I'm saying. Okay, everybody got the same answer. So this is 10, 11, 12, 12.5. So this is 12.50 plus this one here is 0.00. So the answer is 12.50. Yes, I think that calls for some celebration. Yeah. Okay, let's go on with the E. So go on with E. Dara Simi, how did you get 8.6? Okay. Now, I think I see what the problem is. See, this is 5, this is 6, this is 7. We don't have any 0.5 here. There is no 0.5 here. So we'll leave it as 7.00. There's no 0.5. We don't see anything coming down here. So 7.00. So here is 0, 1, 2, 3, 4. That means 0.40 or 0.04. So the answer is 7.04. Yeah, because 4 times 0.01 is 0.04. So the answer is 7.04. Yeah, I believe some of you can see your mistake now. There is no one that came down. NIB. There is no one that came down. Okay, so do you now understand? Okay, I see people have moved to the next one. These guys, you guys are on fire. You guys are doing a very good job. But amazingly, from the answers I've seen, it looks like only Folake got the answer. Yeah, Ami got it. Of course, Rubik's, it should get simple. So, look at this. This is 10, 11, 12, 13, 14. There is a 15 here. There is a line here, 15. You can even see it's written. So that will be 15.00. Then this one is 5, 6, 7, 8, 9. 9 times 0.01 is 0.09. So I will have 0.09. So the answer is 15.09. So Folake and Ami got that correctly. I hope you all can see your mistake. 5.9 is not the same thing as 5.09. It can never be the same thing. Yes, Ami got it. So 5.9, 5.09 is not the same thing. 5.9 is bigger than 5.09. Okay, yes, I'm glad you can see your mistake. Dojan. Okay, so let's do two more. Two more, then you continue. So give me the answer for G and H. Give me the answer for G and H. Enaibe, what is it that you don't understand? Enaibe, but you were giving answers now. You are giving correct answer. Okay, I like the answers I'm seeing. So let's do it together. So this one, this is 10, 11, 12, 13. There is a 13.5 here. So you have 13.50. Then here you have, this is 30. Here will be 31. So 31 times 0.01 is 0.31. So you have 0.31, 13.81 millimeters. So if you got 13.81 millimeters, you got it correctly. 13.81 millimeters. I hope you can see your mistake for the first one. Then the second one, this is 0, 1, 2, 3. There is a 3.5 here, down here. So I'll say 3.50. Then here is 35, so 0.35. 3.85. You guys are ignoring the other one. Enaibe, please, you go through the video. Go through the video because I'm moving to the next one. Go through the video. After the class, you can go through the video again and check the mistakes. But by the way, Stanley, which one is 5.6 again? Okay, you guys are fast though. You guys are already moving than the speed of light. I didn't say you should move to the next one. No, I'm done. I'm tired. So don't forget the 0.5, especially when you see it. Don't forget to add that. Okay, I'm glad that you guys now understand this. So we should move to something else. Okay, so let's discuss something else, please. If you are ready, tell me you are ready. I'm going to be dropping it on the group, so you guys should work on that. Okay. NIB, just watch the video. Let's move on. Watch the video. This is, you came very, very late. So, okay, good. So, now this is something else. Okay, this is something else we want to look at. Okay, let me leave this. Okay, so the other measuring instrument we are going to look at is stopwatch. Now, but before I continue, I'd like you guys to remind me, what is the resolution of a stopwatch? I mean, of a meter rule. What is the resolution of what is it called? Vernier caliper. And what is the resolution of a micrometer screw gauge? Can you go ahead and write it? Meter rule. We have seen three instruments now. The first one we saw was meter rule. Then the second one, vernier caliper. The third one, micrometer screw gauge. And I'm saying that you guys should write for me the resolution. You can write it. I'm waiting. The resolution of these three. Okay, that's a good one. For vernier caliper, what of meter rule and micrometer screw gauge? Ugochukwu, Miriam, that's good. Meter rule is 0.1 centimeter or 1 millimeter. That's right. Ugochukwu, that's a good one. Ami, that's a good one. Okay, I'm glad you guys still remember. Okay, that's good. So let's continue. Okay, so the next thing we are going to look at is the stopwatch. I'm sure you know what a stopwatch is. So, stopwatch measures time intervals. And we have two types of stopwatch. We have analog stopwatch and we have digital stopwatch. One is analog, the other one is digital. I believe that we know the difference between analog and digital. Please give me a second, please. Okay, I'm back. Have you guys noticed that nobody has said, "Sir, your screen, sir, your screen"? Have you observed that? Okay, only Mackenzie has observed that. Okay, Ugochukwu, yeah. So I said I was going to work on it, so I think it's better. It's better now. Okay, so now we say that we have two types of stopwatch. We have the analog stopwatch, we have the digital stopwatch. Then the analog stopwatch is 0.01 second, 0.1 seconds. That's the resolution. Then the digital stopwatch, the resolution is 0.01 seconds. Okay, that's very, very important for you to note. So we use these watches to time experiments, to measure reaction time, to measure period of oscillation, and to measure spot time. let me see if I can show you what a stopwatch looks like. Okay, these are different examples of stopwatches. This one is digital, this one is analog. This is an example of analog. Let me show you. Can you see? This one here is analog. It keeps ticking and you are reading. Okay? If you want to know how long it takes something to happen, you can use an analog stopwatch, but you have digital. These ones here are digital. And amazingly, all of us, we all have digital stopwatches in our phones. Everybody has this. You have something like this that you can use to time something. I hope I'm making sense. Miriam, what did I do about what? So I'm sure you guys can see analog and digital. Do you guys understand now? Do we understand? The two are good. They have their problems. Both of them are good, but they could have their problems. But you know, digital is it's easy to read. It's easier to read. Okay. Then we have the procedure for timing. If you want to time, you start the stopwatch at the beginning of the event and you stop at the end of the event. You record your reading and you repeat and calculate the average. You record your reading over time, then you calculate the average. That one I believe that one is a straightforward something. So now there are other common laboratory instruments, but we will not discuss them very well. Like measuring cylinder, we use it to measure volume of liquids, and the volume is in centimeter cube or meter cube or milliliters. Centimeter cube also means ml. It's the same thing. Okay. Then another one is beaker. We can use it to hold and mix liquids. Okay, even though it's not very accurate. Then we have thermometer, right? Thermometer is used to measure temperatures. The resolution of a thermometer is 0.1 degrees Celsius. Sometimes 1 degree Celsius. That's for resolution for a thermometer. Please note those thermometers. When you're writing WAEC or JAM, those things are important. They can ask you. Okay. Okay, I thought I've changed the screen. Miriam, that's Lifechanger secrets. Okay, so we have what we call weighing balance. Balance is used to measure mass. We have beam balance, we have electronic balance. These are types of balances. Then we have spring balance, used to measure force or weight. These are amazing things. I wish I can show us the diagrams. We have ammeter, we have voltmeter, we have measuring tape. Okay. Maybe what I'm going to do is that I will send you guys this my notes so that you can go through it. I believe that will help you just to see it. Yeah, I know the screen is working. So we have done all this, comparison of length measuring instruments. We have meter rule. The resolution is this 1 millimeters, used to measure length, width, height. Vernier caliper 0.1 millimeters, used to measure diameter, depth, thickness. Micrometer screw gauge 0.01 centimeter, used to measure very small diameters and thickness, very small. Okay. And the accuracy ranking. Micrometer screw gauge is more accurate than vernier caliper, which is more accurate than meter rule. You should note that. Okay, it's more accurate. These other ones are not I won't bother you with these ones. Okay. Now, I want to say this, please. Another word you can see for resolution for your level is accuracy. Another word you can see for resolution in your level is accuracy. So when they ask you what is the accuracy of a meter rule, you say 1 millimeters or 0.1 centimeter. When they say what is the accuracy of a vernier caliper, you say 0.1 millimeters. When they say accuracy of a micrometer screw gauge, it is 0.01 millimeters. Don't forget that. So you may not see resolution, you may see accuracy, but they are talking about the same thing. So that's the reason why the accuracy ranking of micrometer screw gauge is greater than vernier caliper and greater than meter rule. Okay, so that's by the way. Now that leads us to a new topic. I didn't know we will enter a new topic today. So I'm glad to announce to us that we are entering chapter 3. We are entering chapter 3. You guys have done 2 major chapters in physics. Maybe next week. Is it next week or next 2 weeks? We When do you think we should do tests? I want us to do tests. Somebody say next week. It looks like next week may be better. Ami says today. Ami, it looks like you're on fire. Okay, I think we'll do some tests next week. Okay, I can see most people are saying next week. A very hot test. But can you see that we are making serious progress? Okay, so we enter a new topic. Now, this topic, calculation plenty for this topic. Calculation is plenty, so give me your attention. Now, what I want to talk about now is distance, position, and motion. Okay, can you guys see what I've written? Okay, so let's start with definition of terms. Okay, wait. I think I have a note here. Let me check. I have a note on this. Give me a second. Let me check. Okay, I think I can't find the notes. So let's go on without the notes. Okay, so you can write that position is defined as where an object is, or where you locate an object with reference to a particular point. Do we understand that definition? Do we understand that definition? Okay, good. So now usually we use coordinates to represent position. I'm sure you know what coordinates is. Some of you know what it means to plot a graph. If you plot a graph of y against x, unless something is located here, let's assume that if you trace it here, this is 3, and you trace it here, this is 5, you will say that this point is located at 5, 3, representing x and y coordinates. So usually we use coordinates to represent position. Okay, so y3 representing x coordinates and also y coordinates. I hope that makes sense. Okay, I'm glad. I love that. I love your responses. They are very soothing. Okay, good. Very good. So the next thing I will talk about is distance. Okay. So distance is the gap between two positions. Okay. So distance separates one position from another position. That's very important. Okay. So let's assume that I have a position here. This position here is position A. I have another position, position B. I can use a ruler to measure this. There is a formula for distance, but further maths, those of you doing further maths will look at that clearly in the future. Then number 3, okay, you can add that distance is measured in meters. Distance is measured in meters. Okay, so number 3 would be displacement. Okay, so displacement is distance covered in a specified direction. And yes, the person that has written that, I like that, is measured in meters. This meters is called the SI unit. Standard International Unit. Sorry, I'm attending to something. Okay, are we done writing? Because I want to tell you the difference between distance and displacement. Are you done writing? If you are ready, say yes, I'm ready. If you're ready, say yes, I'm ready. If you're ready, say you're ready. Okay, good. So now I'm going to use questions to differentiate between distance and displacement. Now look at this. Okay, but before I continue, difference distance has no direction, but displacement does. Distance is what we call a scalar quantity. But displacement is a vector quantity. Okay, I think these two are enough. Okay, now look at this. Let's say okay, so we want to use this question to differentiate between distance and displacement. Very, very important. So I want you guys to write the question quickly before I continue. No, please don't attempt. Let me just explain. So watch. A man walks 5 kilometers due east. Due east is to the right. So the man walks like this, 5 kilometers due east. And then he now walks 2 kilometers due west. Due west is to the left. Now watch. If I am asked to find the distance means everywhere the man walked. That means 5 plus 2. So the distance is 5 kilometers plus 2 kilometers, which is 7 kilometers. But the displacement is not. Look at the displacement. Displacement means the distance from where he started to where he ended. See where he started. See where he ended. This space is the displacement. So, and for us to know this space, from here to here is 5. From here to here is 2. That means the remaining of this space is 3 kilometers. So that means his displacement is 3 kilometers. Meaning that he didn't go far. Meaning that he didn't go far. So you can see that his total distance is 5 kilometers. I mean 7 kilometers, which is 5 plus 2. But the displacement is 3. He didn't go far. That means from where he started to where he ended was 3 kilometers. Even though he has trekked for 7 kilometers. Hello, are you getting this? Do you understand this? If you do, I'd like to see your response. Okay. Now, let's listen. Okay, I'm glad. Okay, you guys understand it. Very good. Very good. So that's the difference. So, if, let's say a man wants to travel from point A to point B. Let me just give another. Let me say somebody wants to travel from point A to point B. He can, how our roads are. Sometimes you will go like this, sometimes you will come like this, sometimes you will come like this, you will go like this before you now get to B. Can you see the stress this man went? But if you are using an aeroplane do not calculate distance. Aeroplane calculate displacement. You can see that he will just move from A straight to B. So you can see that distance sometimes can be much longer than displacement. Why move through all of this when I can just go from here to here? That's the reason why if you want to travel from, let me say for example, from Abuja to Lagos, you can use 8 hours for that journey. But if you enter flight and aeroplane, flight takes you in 1 hour or in 45 minutes. That's because flight works with displacement, but car works with distance. Now where road dey, now you go follow. Hello, am I making sense here? Am I making sense here? If I'm making sense, let me know before I move to the next thing. Okay, good. Okay, good. Any other response? I need as many response to let me know that I am making sense. Okay, good. I'm happy to see that. Okay, so then now let's see another type of question. Another question that will help us differentiate between distance and displacement. Look at this question. Okay, so let's see another question. Okay, Mackenzie, nice one. So let's do this together. Now watch. A car travels 5 kilometers westward. This is west. And now he now travels 12 kilometers northward. This is north. What is the man's distance? Distance means all the wahala, which is 5 kilometers plus 12 kilometers. That will give us 17 kilometers. That's the distance. That's all the distance covered. But if I want to find displacement, to displace means see where he started, see where he ended. That means he's meant to go like this. That's the displacement. So I can call here x. Now if you look at this now, this forms a triangle. If I want to find x, this is a right angle triangle. So I can use what we call Pythagoras theorem, which I believe many of you should know. According to Pythagoras theorem, the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. It's called Pythagoras theorem. So what that means is that this is x squared is equal to 5 squared plus 12 squared. So that means x squared is equal to 5 squared is 25, 12 squared is 144. So x squared will be equal to 169. That means x will be square root of 169, which is equal to 13. So the answer is 13 kilometers. The displacement is 13 kilometers. The displacement is 13 kilometers. Have you guys never heard Pythagoras theorem before? Meaning that it didn't go far. So you can... Yes, Pythagoras theorem is applied for a triangle now. The first one is not a triangle. Pythagoras theorem only happens in a triangle. So this is a triangle, a right angle triangle. This is called a right angle triangle or right triangle. Okay, so we call this Pythagoras theorem. Yes, I like the fact that Darasimi stated that you guys have learned this in GSS 2. You should hear about it. So the adjacent squared is plus the opposite square is equal to the hypotenuse square. Even you, when you are traveling, if you see, let's say you have position A here, and you have to go, you have a main road, you have to go like this to go like this to position B. Many of you will rather take the happier way, the shortcut. We call it shortcut. If you know your mathematics, you will know that this is your shortcut. You can calculate the distance. If here is 4 and here is 3, it means that here you can calculate it. It's x. According to Pythagoras theorem, x squared is equal to 3 squared plus 4 squared. X squared is equal to 9 plus 16. X squared is equal to 25. X is equal to 5. You see that? Very easy. Very easy. Very easy. Yeah, Mackenzie, we are talking of Sokatua. That will be later. I can't find George, Tony George. Is he here? Yeah, Pythagoras triple is gotten from Pythagoras theorem. Okay. Okay, so what matters is that you guys understand what I'm doing. Do we understand? Do we understand? Hello, do we understand? Okay, very good, very good. I'm happy to see that. Okay, now before I continue with definition of terms, let's continue with motion. Okay, that's number, let's just say this is number 3. Let's see number 4, motion. So motion is the change. Good. Okay, Tony, I can see you now. So motion is the change in the position of an object in time and in space. Motion is the change in position of an object in time and space. What that means is that if you leave one place and move to another place, you have done motion. You have exhibited motion. That's simply what motion is. So for you to move from one place to another place, you have exhibited motion. I hope that makes sense. I hope that makes sense. Okay. Now, there are different types of motion. So, these are the 4 types of motion. The first one is called translational or linear motion. The second one is called circular motion. The third one is called oscillatory or vibratory motion. The fourth one is called random motion. Now let me say this, there are other types of motion, but for your level, we are limiting ourselves to this. So translational motion, circular motion, oscillatory motion. Oscillatory is also called vibratory motion. Then we have random motion. Okay, so I want to explain each of them, and that's how we close for today. Now, the first one I may mention is translational motion. So I need you to write, number 1, translational motion is the motion of an object in a straight line. When you move straight, is translational motion. The word linear means straight. Okay, maybe I should write that down. So translational motion is the motion of an object in a straight line. Translational motion is the motion of an object in a straight line. Now then the second one, circular motion. Okay, so oscillatory motion is to and fro motion. Anything that goes to and fro, like pendulum, swinging pendulum. You go up and down like spring. You jump up and down. So anything that goes to and fro is an oscillatory motion. Okay. Okay, Aristoteles, you are doing the Lord's work. That's right. That's very correct. So zigzag motion can be, you can go anyhow. This zigzag, no direction, very regular. So these are the 4 types of motion. These are the 4 types of motion. Escalators is translational. Is motion, you can call that motion under gravity. It's translational but in the vertical direction. Yeah, the motion of butterfly, yes, that's random. Yes. Okay, are we all clear on the things I've shown you? Are we all clear? Okay, Tony George, circular motion is not exactly the same thing as rotational. They are different. So for now, you can say they mean the same thing, but they don't mean the same thing. Rotational means something is rotating about its axis. Circular means you are traveling in a circle. So they are not the same thing. Yes, random motion is like moving in whatever direction. Zigzag, it just moves anyhow in different direction. Like dust particles, dust travels randomly, dust, and so on. Are we clear? No, oscillatory motion is not about sound. No. Even though there is an oscillatory motion in sound, but it's not all about sound. Yeah. Sound majorly is produced by oscillatory motion. In sound, you call it vibratory motion, vibration. Like when you vibrate a drum, sound is produced. That's vibratory. Yeah, oscillatory. So that makes sense. Okay, somebody saying jugular, jugular. The students. Okay. So I think we've done a good job today. What do you think? I think we've done a very good job today. No complaint. So you guys are going to congratulate me for no screen issues today. Then secondly, no, is here. What is wrong? On it. You guys are supposed to calculate me with for screen issues today. Then secondly, next week, I think we should write test next week. Now I'm going to write the topics we have covered. Yeah, we really learned a lot. I'm going to write the topics that we have covered. Then if you missed any video, you can ask me to send it to you so that you can practice for the test. Throughout next week is going to be test, a very hot test. Okay. Bye-bye. 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 You're welcome. You're welcome. You're welcome. Yeah, you have a lot to enjoy. So prepare for my test next week. You're welcome, Mackenzie. Yeah, I'm happy. I'm happy. Bye.